Reaction with porous catalyst at large Thiele modulus. A porous pellet with the platinum dispersed in it is used to carry out a catalytic reaction. There are two scenarios possible. Scenario 1, platinum present throughout the pores of the pellet is used for the catalytic reaction. That means the entire pores are used for the entire pores of the catalyst is used for the catalytic reaction, which means the pores are freely accessible. Only then this is possible. And now the platinum present only in the immediate vicinity of the external surface of the pellet is used for catalytic reaction. That means whatever the platinum available at the interior of the pores are not accessible for the reactant to go through. That means here this is one is implying no pore diffusion resistance. Here it is, there is a strong pore diffusion resistance. Okay, out of these two scenario, which is correct, we have to identify. Okay, and it is given that. At large value of Thiele modulus. Okay, always this is a question. Large value of Thiele modulus. Here, always the condition given is Thiele modulus is large. So, which of the following is correct? So, for a first order reaction, rate is proportional to this concentration. Okay, and the proportionality constant is rate constant, and this is effectiveness because of the presence of a porous catalyst. We have this effectiveness factor. So, the effectiveness factor is equal to 1 if there is no pore diffusion resistance, and in the presence of pore diffusion resistance, the effectiveness will be decreasing or it will be less than 1. Okay, so the effectiveness factor is related to this Thiele modulus by this. So which is effectiveness factor is equal to tan h of this ml refers to Thiele modulus. Now we have this nice plot which is saying about the effectiveness versus Thiele modulus. For Thiele modulus value less than 0.4, of course effectiveness is roughly 1, and for Thiele modulus higher than 0.4, we say like we feel this effectiveness is having inverse relationship with Thiele modulus. It is already mentioned that Thiele modulus is higher, so the effectiveness is inversely proportional to Thiele modulus. So this effectiveness is now in this regime. So here it is strong pore diffusion effects are there. So always L is more. If the length of the catalyst is more, so the catalyst the gas cannot go through this entire pore and react on the catalyst surface. Okay, so in that way you can easily say like for large porous, large length catalyst, large length of pores, this effectiveness will be definitely reducing. Okay, this is reaction rate is much greater than the diffusion rate. Okay, that is correct. Scenario 2 occurs. Scenario 2 is platinum present only in the immediate vicinity of the external surface of the catalyst is utilized for the reaction. Fine. So this is the correct answer.